There we go, and we are live. Welcome to another Community Office Hours. Today with the Nomad folks, Michael and Tim. Thank you both for joining me. We'll get to introductions in a second. First, very important, if you've been here, you know how these office hours work. If not, quick reminder. Our office hours are a professional event, so that means be inclusive, friendly, and welcoming. If you see something that doesn't belong here, let us know in the chat. We have moderators on standby. Generally, we don't need them. Y'all don't look like the crowd that would need moderation, and I appreciate that. So with that, let's get to the fun stuff. Michael, I'll start with you because you're on my left side. What do you do at HashiCorp?
Yeah, thanks. Hi, everybody. My name is Michael Schurter, Schmichael just about everywhere on the internet. And I am the Nomad team lead, and I've been here quite a few years at this point.
Are you company furniture at this point?
Yes, very much.
Excellent. Tim, welcome.
Hi, I'm Tim Gross. I'm a staff engineer on the Nomad team. I've been around about 3 years.
Excellent. I just hit my 3 years, so congrats on making it 3 years. Beautiful. So the reason we're gathered here today, other than answer questions from the community, is of course, in our last office hours, I think it was the March edition, you had just posted the load shedding in the Nomad Eval broker blog post, and we had people in the audience asking, can we talk more about this? So first thing we'll do is get a link for that blog post in the chat, so you can read it afterwards. But can you briefly take us through what this is all about? Why are we excited about this?
Sure. So when Nomad has work to do, when the Nomad schedulers have work to do, we use an evaluation as the object that we pass around, and it's kind of like the unit of work for the scheduler. And we call that an Eval for short. And those are handed out. They're run on all the different followers, on all the different servers. We process those on all the servers, but we hand them out from the leader. And so the leader has a process on it called the eval broker, or the evaluation broker, that's in charge of kind of handing out the work to the different schedulers. And one of the things that was happening with that was that when the schedulers got really backed up because there was a lot of changes to the cluster all at once. This is really the only sort of thing that you see on very large clusters, thousands of nodes, where say 10% of the nodes decided to all go offline because there was a configuration management issue or a network connectivity issue. Every one of those client nodes would then have to send would result in at least one evaluation being sent, because what happens so those clients are all heartbeating regularly to the servers, right? And when we lose that heartbeat, we need to reschedule the work that was on those clients. And so the leader will then say, okay, we're going to emit a new evaluation for every job that was running on that client, or every system job running in that data center. And so that can result in, say, if you have 100 different jobs running on a client, then when it goes out of, when we lose connection to it, or when it comes back online, we end up emitting 100 evals. And you multiply that by, say, 1,000 nodes, and you have quite a lot of evals being generated. And unfortunately, as it turns out, if the work doesn't need to be moved, if the client is flapping, right? So it's gone offline, it's disconnected very briefly, and then come back. Oftentimes, those evaluations are no ops, right? There's no work to be done. But the scheduler still needs to queue it. The scheduler needs to process it, go through all that very computationally expensive work to figure out there's no work to be done, and then acknowledge it back to the leader. And that creates a bunch of raft traffic around the cluster of the servers. And so what we really wanted to do is find out a way to could we reduce the amount of traffic that we were could we reduce the amount of evals that we were generating in that case, so that way we don't have to process as much work. As it turns out, We can't. We can't stop those evals from happening quite, because it's really the leader, that eval broker, that needs to decide whether the work needs to be done or not, or whether that work is duplicate or not. And so what we're able to do was to make it so that when that work started to pile up in the eval broker, we were able to say, hey, let's find all the evals that were for this job, and as an eval is acknowledged by the scheduler, we were able to then say, okay, we now know that at that point, we only need one eval for that particular job to still be in the queue, and everything else we can throw out. And so that allows us to shed an enormous amount of load in these circumstances. And one of the things in some of the tests that we did in the blog, it can drop like the RAF traffic involved in this kind of thing by like 90%, which is obviously very significant for large clusters.
Very
That's
significant.
the short version.
That is definitely a short version. The blog post is beautifully documented. I like the fact that you actually put in diagrams explaining how these operations work. It's important. It's not the stuff you would normally look at as an operator necessarily, in my experience, but it's useful to learn, because the more you know about why your cluster might be slowing down, why your operations might be, your services might be flopping, the better you can anticipate and architect around that. And especially if you're new to a technology, I like knowing what's happening in the background. Imagine you're switching to more edgy stuff. You might actually have your services disappear and reappear, cause extra evaluations. It's always good to know. With that,
Yeah,
let's see if
I want to kind of just like jump off that for a second, because I think it's a really important concept for Nomad. Is we talk a lot about the simplicity of operation, right? We want to make Nomad as easy as possible to understand. But I think there's always the kind of like, and so there's kind of always a layer of abstraction that we want to have, that you don't necessarily need to get into the guts of things. But I think that, once you really start to get to the very large scales, any system really kind of starts to show, like really understanding how the guts of something works really start to benefit, whether it's, your orchestrator, or whether it's your database, or, if it's Postgres, knowing how Postgres connections work is really important to operating Postgres at large scale, right? And I think that applies to pretty much any technology you're working with.
absolutely. I think, Michael, you've got the right poster hanging in the background. You're never too old to learn. It might be hard to read depending on how you're watching this. I know we sometimes have people join from mobile. I truly appreciate that. But yeah, you're never too old to learn. And the more you know about your technology, the better you'll be able to use it. I love that. These are the kind of blog posts that are beautiful to read when you have some actual downtime and can dive into. And I see in our chat, if you're joining us, thank you for letting us know where you're from. We've got people from Nevada and New York, or New York City in this case. Welcome. Where are you two hailing from, actually? Normally we do that at the beginning.
I'm hailing from very cloudy today, Portland, Oregon. Yeah, Tim?
And I'm in Philadelphia.
Beautiful. Well, Amsterdam is still cloudy, confirmed. I feel like just evade the outdoors and just enjoy the indoors and actually learn something. So in the tweet for, or in the actual, like all the social that we talked about for this office hours, we mentioned Project Fortify. I'm a sucker for code names, especially cool sounding ones. What is Project Fortify?
Want to take that one, Michael, or oh, okay, I'll take it. Okay, so I think we sometime this summer, I want to say it was, we started having an internal discussion about wanting to have some focused time around improving reliability and performance in Nomad. I think it's when you are obviously we're always trying to bring out new features to folks, but I think it's good to sometimes take a pause and say, okay, you know what, it's great that we're doing, we're rolling out features continuously, but we also should make sure that, all the fundamentals are still sound, and invest a little bit of time into that kind of thing. So Fortify is kind of a body of work, we're kind of like our internal code name. That's a body of work that we're doing around finding problems like that eval broker problem and kind of spending some deep time on them. Like fixing things that are maybe not bugs per se, which, because I think that's a really good example of like, it feels buggy if you're going through it, but it's like, well, everything's behaving as designed, but maybe the design needs a little improvement. So things like that, some of the weirder, kind of more esoteric bugs that we had been taken a while to figure out, but also just doing things like documenting some of the internal architecture. So I've been producing a bunch of like documents and diagrams that we're sharing with the community in our contributing guide around how some of the internals work, so that when new contributors come on, they can read those and have a better idea of like how, not just like from reading the source code, which is pretty readable, but source code is source code, and so having kind of a higher level view of like how the details work, so to speak.
I think that's it. Documentation is incredibly important, even extra documentation like these blog posts. Yes, you can dig through the source code, but sometimes you don't want to, and sometimes that's just not the thing you have time for. So this helps.
Yeah, and I think to add what Tim was saying, I think a big reason for the push behind Project Fortify was just acknowledging that our performance and behavior in the steady state stops mattering once you hit the edges, the failure conditions, the disaster recovery scenarios. And so, like this load shedding in the Nomad Eval broker has some great benefits for the steady state, can absolutely save you in the case of large-scale node outages or large-scale node flapping. Large-scale node flapping can cause tons of evaluations to be created because nodes are coming back, leaving, or maybe not even leaving. Maybe just some state around that node is changing, is flapping back and forth between two states. That makes the scheduler reevaluate that node. That can create immense pressure on the scheduler. That can cause not just a backlog, but also distract you from discovering what is causing that flapping to begin with, potentially. And so really focusing on making sure that at the edges, at the failure conditions, we can maintain the same reliability and performance as we do during the steady state has been a big focus here.
This is beautiful research to carry out. It's, as somebody, who professionally debugged stuff that was broken, usually I would look at my own operational code and not so much towards the orchestrator I was using. This is beautiful to learn from and to hear about. And also I can't state this enough, read this blog post. The methodology that's used, it might not 100% apply to how you debug your own systems, but it's solid and it works. And I think that's what I like about office hours is the most. We come together and we learn from each other. People bring good questions. In this case, you two bring a beautiful blog post to learn from, and helps.
And two, if you're just running a 10 node or whatever Nomad cluster today, just a few workloads on it and getting started, we want these sorts of blog posts and community office hours to be an opportunity to build your knowledge and confidence so that as that cluster grows, you are confident that Nomad can scale with it. And that is what Nomad has been designed from the very beginning to be able to do. So you should hopefully not have to think about it at the time, and instead just be able to enjoy these community office hours and blog posts at your leisure.
That is a beautiful call out. Usually at one point or another during office hours, we bring this up. Feedback is important. If you're operating a system, feedback is important. If you're deploying to a system, feedback is important. For us, feedback is important to understand how you're running Nomad. What are you running into? Are there sharp edges that you don't love? Let us know. Head on over to GitHub, drop us an issue there. The better your issue, the easier it is for us to help us and help you, help everyone. And help us discover what those sharp edges are. The input we get from our users has been, I want to say, fundamental in making improvements. Ultimately, Nomad is used in the wild very successfully and very extensively, and that's how new features are born. Of course, we could all get together and think up new features. That's not going to be nearly as useful as you, the community, telling us what you're looking for. Where are you running Nomad? Are you running it on some type of hardware that we might have never heard of? Are you running it on very underpowered hardware? Last year at HashiCorp, we had a beautiful example of somebody running it on either Raspberry Pi 2s or Raspberry Pi 3s, which creates a whole different architecture and requirements set. They're useful things for us to know, so don't be shy. Anything to add?
I think some of my interactions I've had with folks on GitHub have been really amazing in terms of letting us know where kind of the boundary conditions of Nomad are, right? Where they're saying, hey, we've configured this in a way that the system lets us configure it this way. This isn't like there's no docs saying don't do it this way. And so we're doing it this way. So shouldn't it be fine? And we shouldn't be seeing this kind of behavior. And it turns out that this is maybe an unanticipated set of combination of features or combination of configuration values. And so it's been really great to have folks coming in with those, because then it definitely is a whole new area to start exploring. Oh wow, we have Schmeichel and I were having a conversation earlier this week about the rate at which clients send their updates is something that we're going to be starting to look at in the next few weeks, because it's hey, there's a real potential to improve in performance there, and a lot of that has come from folks in the community.
Michael, anything to add to that?
There's so much to talk about. But I did see Daniel in the comments mention that they have hit the dreaded eval backlog problem. Oh, perfect. Thank you. So Daniel, if you're able to update your comment, I would be super curious if you are on Nomad 143 or later, right? Is that when this shipped, Tim? Okay. Oh yeah, by upgrading to Nomad 143 or newer. Yes, 143 is the cutoff for these improvements. Because this sort of behavior is exactly what these improvements often help with. Those pending and blocked evaluations are the evaluations that are in the queue in that eval broker waiting to be processed. Now, there is one sad thing in this statement that probably only Tim and I notice, and hopefully, okay, great. Hopefully that'll fix everything for you, Daniel. But in your previous comment, there was one word in there that makes me really sad, and hopefully that will be fixed in 143 and newer as well, which you mentioned blocked evaluations. Did you fix that label in 143, Tim, or when did we fix that label?
It's I want to say it might be 1.5. I forget.
Okay.
But go ahead.
So words are hard. Terminology is impossible. Staying consistent is really difficult. So we used the word blocked evaluations in two different ways in Nomad. From basically the very beginning, basically Nomad 01, all the way through until when we finally fixed the label. Oh yeah, I think that is in 1.5 because it does change a metric label. And so we wanted to do that during a major release, so we're not changing people's graphs out from under them during a patch release. Prior to 1.5, blocked evaluations prior to 1.5, on the broker object in your metrics. So if you're looking at the blog post, there's in some of the graph it mentions like broker.total pending. There was a broker total blocked. Total blocked means pending in that context. That is an evaluation that is for a job that has an evaluation currently being processed for it. And so it is blocked on that other evaluation to run. The other definition of blocked, the definition that we're keeping, is when an evaluation cannot be fully scheduled. So say you're out of capacity in your cluster, or maybe that job has constraints on it so that it can only be scheduled on certain nodes, and those nodes are full right now. We create what we call a blocked evaluation that says, well, we couldn't finish this evaluation right now, so we're going to store it and reevaluate it whenever anything changes. So whenever anything changes, we pull evals off of that blocked queue and evaluate them again and put them back. And there's all kinds of neat optimizations there as well we could talk about someday. But that is the definition of blocked that will stay and is almost always capacity related, cluster capacity related.
Beautiful answer. I see Daniel is intending on updating to 1.4. Go to 1.5 directly. Get free SSO, no SSO tax incurred here. It's beautiful. It works. We looked at it with James in the last office hours. I've never seen SSO demos that worked as cleanly as that one. And that's saying a lot because I've had way too much SSO in my life. And it was never, the first S never came to pass. Meanwhile, we have a couple of interesting questions in the LinkedIn comments. I'll take this one. Is Nomad for production? I would say we could tell you all about this and say yes. An easier way to see how this goes is to look at some of our customers and what they do. Roblox particularly, huge fan. I would say check with them. What do they love? What do they do with Nomad? They're running a small-ish gaming platform on Nomad. It seems to work well. My personal favorite still remains eFishery because I think the whole concept of running a spread-out architecture that's running on Raspberry Pi 2s, I looked it up in the meanwhile because it was bothering me. So 7-8-year-old hardware in 2022, beautiful. All right, let's see what other questions we have. Daniel is very appreciative of the input. So I think we're getting in the right direction here. And there we go. As it should be.
Excellent. Excellent. Yeah, I could absolutely see how any node flapping in that sort of situation prior to this optimization could create quite a scheduler backlog. When you're running that many jobs, or workloads. Also, as far as the production question goes, I'm having trouble finding our best Flogo page these days, but HashiCorp.com/Nomad has at least a few of our users and some good leads on people using Nomad in production there. But yeah, you can find examples of people using us for small clusters and little jobs. I was talking, well, I can't say that name publicly, but a friend at another startup using Nomad just right now for system and sysbatch jobs, kind of like a little bit like they use config management today, like Salt or Puppet or Chef. They were just using it to manage kind of the base infrastructure layer of some nodes. And we're hoping if that went well, they could build it out from there. So there's everything from that all the way up to, the many thousands of nodes clusters running out there in production and everything in between.
I think that's where it gets interesting. You mentioned this earlier, Tim, get to know your tools, no matter if it's your database server or your orchestrator, because the more you know, the better you'll be able to use it. Nomad is just very much a Swiss Army knife, and depending on what tool you use, you're going to get a different experience and a different success story. I love the idea of using Nomad to replace my aging chef scripts and Puppet scripts. I hadn't thought about that. That's very shameful. This is definitely something that we should probably talk more about, because those use cases make for novel use cases. I like it. Let me see what new questions we have and get rid of this one in the meantime. Yeah, definitely upgrade to 1.5. Free SSO. Very important. Before I throw my next question at you, is there any more that you want to add to Fortify, on Fortify?
Yeah, I mean, so I think some of the other like fun projects that we're doing with that, there's we did a big push around RPC rate metrics, which is kind of one of those things. It's like, well, you're not fixing a bug, you're not like making things faster, but what we did was we wired up our the entire RPC system, which is the communication between all the different agents, so from clients to servers and servers to servers, so that all those interactions are now measured in terms of like the number of requests that come through for each endpoint, and I think it's like split on writes and reads and lists. So that you as the operator can then take those metrics and put those into your metric system and use that for debugging when things are going unexpectedly, right? So you can then say, hey, you know what? So here's an example: is like a lot of our users have we'll put some kind of layer on top of Nomad's API, right? So they have a system that's like, we have really precise timing of placements, or we want to make sure that or they're using something like the Nomad autoscaler, which is responds to load changes and then launches jobs as in response to that. And being able to know the source of those requests is really important for understanding, like, hey, is one of our orchestrators, is it like, are we overwhelming the cluster by sending, it got into an infinite loop, is like sending a ton of data to us, a ton of like requests that we didn't expect to have. And those kinds of things are the sort of thing that you'd be able to like use those metrics for. So some of it is about like making the system more observable. And then other things are like, we were talking about really old bugs. We had this bug that was kind of the notorious, we called it the plan for node rejected bug, which was, so Nomad scheduler is optimistically concurrent. So we're running the scheduling process on many schedulers all at once, dozens usually on a larger cluster. And then they all have to kind of serialize through this plan applier. And there was like this particular bug that we could get into where the scheduler would come up with a plan and it would always get rejected, and it would get into a loop, and that plan would continuously get rejected. And so it turned out that, and this was kind of like a very, we took a number of attempts at discovering the source of this bug because it was the sort of thing that you couldn't reproduce without quite a bit of, as it turns out, you couldn't reproduce it very easily unless the node on which the placements were happening had its dynamic port range very packed. So you really only saw it if you had a lot of workloads on a given node. And so that's sort of thing that's not necessarily easy to reproduce in local development environments. And so, yeah, so like basically it was like if the scheduler got a port conflict, it would get into a loop where it then couldn't ever place them, and so we had to fix that. And so those kinds of like long-standing bugs are the other sorts of thing that we're trying to hunt down as part of this Fortify work.
Yeah, and I think with this bug in particular, it was a very long road to get this fixed, and there were kind of similar bugs that could cause that same plan for node rejected that we found along the way. But this one in particular was kind of the biggest, the most commonly hit, I think, and kind of took the longest to diagnose and discover. But part of Project Fortify, like Tim was talking about with the RPC rate metrics, is about building more observability tools and making Nomad easier to observe, not just for you, but hopefully for us when you come to us with GitHub issues or if you're a customer and coming through HashiCorp support. We really rely on these detailed logs and metrics. Send us screenshots of your dashboards. All that sort of stuff is great and can really help fix some of these really tricky bugs that rely on just really specific sorts of states to get into. There's even a Nomad operator debug command in the CLI that feel free to play with. It's people running against production clusters all the time. It's used heavily by our support team to kind of gather debug bundles, we call them, from our users. But it might be kind of fun for people to play with too, just kind of get an idea of what we like looking at when it comes to debugging production clusters. There's wonderful metrics from the Go runtime in there. The Go runtime is just fantastic as far as observability goes. And then there's all kinds of things like node dumps and profiles from the Go runtime, job dumps. Yeah, it's kind of a cool thing, and it might be kind of interesting to peek at if you're wondering how our debugging usually goes.
I want to add to that. If you're using any of the hosted monitoring tools, Datadog, New Relic, their dashboards can be exported. So if you find yourself in a situation where you're seeing something in your reporting tool, in your metrics, that doesn't make sense, help us out by exporting your dashboard's configuration so we can see the exact same thing with our test case. It makes it easier for us to debug. And yeah, like Michael said, definitely look at the archive that we built with log files. There might be interesting stuff in there for you, but it's also good to know what you're handing over before you hand it over. And test it out when your cluster is not at full load and you're looking at several hundred megabytes of information, but do it from the start.
Yeah, I just want to, before we move on, I really always encourage people like shell into prod, right? And this is like, I know, and that's very controversial, right? In the DevOps, but like shelling into prod when things are going well. I don't, it's not just the act of shelling in, but it's actually like, going and looking at what are your metrics telling you, what do your logs look like when things are going well, helps you understand when things are going wrong. So I just always encourage people to, try to find the time to do that, because I think it gives you that chance to say like, hey, hey, that's funny is always like, this is often the start of a new like exploration, either an exploration to learn or an exploration of, hey, we've got something that's like an incident that hasn't yet happened and that we can get ahead of. So that's always good to do that.
It's always good to know how your system runs in all different states. Don't do your system health checkups only when stuff is broken. For that matter, since you're a human, don't do your checkups only when stuff is broken. Do it earlier. Your system will thank you for it, both types of systems. Let me see. There was a question that I wanted to briefly grab. The chat on LinkedIn has been popping off, and I appreciate that, but it also makes it a little bit harder to find all the things that we're looking for. Almost there. There we go. Does Nomad use Packer to deploy applications that are not containerized? The short answer here is no. I'm just going to jump in here and answer that. Unless you use Packer to build the images that you use, the archives that you use Nomad to deploy with. Nomad has a concept of task drivers. Generally, if you're not containerized, you could be looking at running actually a binary like through exec or raw exec, probably one that isolated, so you will probably want to go with exec. Of course, depending on your system setup, you might have jars, Java archives that you want to run with. Which other ones do we have? QEMO. Help me out here. I'm not.
Well, so isolated fork exec, which is like the raw exec, except it's with a container that Nomad builds. And I think there's like a really interesting wealth of community task drivers too, where folks are saying, hey, I have a workload that doesn't really fit in any of these things, and there's kind of a nice, a fairly well-contained interface to write your own task driver. And we definitely have seen some pretty cool ones like a containerd task driver. Some folks, I think it's Roblox, did an IIS task driver, which is the Windows web server, built-in web server, which is kind of cool if that's what you're into. Someone's done a systemd ephemeral task task driver. So there's really kind of like and we've definitely internally done on like fun hack days. Like one of my colleagues, Daniel, recently did like a thing that created Ableton music tracks. That was the task, which is kind of like just a really fun experiment, but it kind of shows kind of the giant range of things that a task driver can do. Nomad was really more concerned about, let me schedule that, and then it's up to the task driver.
There are whole startups that are Nomad with Wasm or Firecracker task drivers. Wasm and Firecracker are probably the two of the most like popular task drivers that we see like various implementations of, and would be great to like productionize someday, and we just haven't quite figured out the best path around that yet. But yeah, lots of exciting task drivers out there.
I think that's also the power. You start out with a few that are integrated, and then go from there. Depending on what your system needs, and make sure you don't have everything in there if you don't need it. Nomad is very conscious about it, but as always, any software that you don't load and that you don't have on your system limits the attack surface. And then, as Tim says, if IIS is your thing, the Roblox task driver is actually a pretty cool one. I want to say at HashiTalks Build 2 years ago almost, we talked about that a lot, and we also had somebody else from Roblox join us explaining how Roblox debugs issues with their Nomad setup. If that's the kind of thing you're into, definitely find those clips on YouTube. But we also have HashiTalks Build happening again in August this year. August, I'm going to say 9 and 10. That's the one. So feel free to join us. It's an event dedicated towards people who build with our tools. If you're building task drivers, if you're building plugins, providers, whatever you have, it's the space to be. You'll get very nice, I think as my colleague put it, hardcore technical content that you won't find anywhere else. I'm not sure if that's CorpComm's approved messaging, but we'll go with it because that's what we expect here. And while I have you two here and we have all these folks watching us, what can we see from you for HashiTalks Build? You're both on mute. I'm sure that's by accident.
Oh, whoops. No, I don't know. I don't know yet. So there's so many interesting things going on. I mean, Project Fortify is going to have a ton of cool stuff. I'll let Tim talk about that here in a second. I have been off working on kind of a cluster of smaller features that are intended to work together, and still going to be improving them here in the coming months. And those features are the Task API and the, improving workload identity and dynamic node metadata. Okay, so those are like the three feature names. Hopefully, Google or whatever will lead you to the right spots if you want to look up more about those. But the story that I wanted to deliver in 1.5 was mainly around, we saw a lot of users want to write like system jobs that run on every node in your cluster, that monitor that node, and then can update metadata on that node depending on like, oh, Dockerd is wedged, so let's like mark this node as having a problem, or disable scheduling automatically or something like that. Or, oh, this node has had licensing. We had somebody with a licensing use case where some software that they ran had to have some licensing system installed first. So they wanted to use a system job to kind of monitor for when that state change happened on the node, update a piece of metadata, and then their licensed software could be placed on it by the scheduler and run. So the way that this cluster of features does that is the task API is a way for your workloads to talk to the Nomad API without having to use service discovery, without having to use TLS and set up MTLS certificates. And it can use a workload identity that we added in 1.4, but then exposed to jobs in 1.5 to authenticate against that task API, so that you can have really fine-grained control over exactly what it is this job can do. Because you probably want these jobs to be able to do things like update the node metadata to say, yes, this node is ready to receive workloads now, or this node is running this version of some software. But that same job, you probably don't want to give it permissions to start and stop other work. You don't want to give it, admin permissions across your whole cluster. And so now with workload identity, you can actually control the permissions given to workloads when they access the Nomad API. So yeah, hopefully all those features work together quite well. And then here in the future, we're hopefully going to make it easier to reuse that workload identity in external systems like console, vaults, and anything that speaks JWT. It's just a JWT right now. So yeah, should be kind of exciting.
I think anytime you're able to scope workloads down to just the permissions that you need and do that in an automated way that works, that is exciting. Security never feels exciting, but when it works, that's perfect. That's great. Especially with all the leaks we see going on, I think this is an important push. Having the old situation with basically a single token, a single way of identifying things. Sure, it works. This is a more solid approach. And having access to JWT or JWT, beautiful. You could use any system for this. Vault, your GitHub Actions, anywhere.
Yeah, kind of a fun little personal story with that feature is that when I a long ways back now was an operator of Nomad before I came to join the team, and I wrote a piece of software that had to talk to the Nomad API that also needed to run on the cluster, and it was so evil to configure this thing because it was like I had it mounting the binary from the host into the Docker container and then giving it TLS. It was the most horrible thing ever, and so I'm so glad that no one will ever have to do that again. So that's kind of fun.
Your definition of fun and mine slightly differ in this. We used to do Halloween horror stories for office hours, traditionally in October, where we would talk about stuff like this. Maybe we'll get together for this year's edition and talk more about this, because this seems like a great learning opportunity for everyone, of things you don't have to do anymore, but also understand why they were necessary in the first place. Also, if you listen to that story, make sure you sanitize your hands afterwards, because it sounds painful. I'm glad we don't have to do that anymore. Thank you both for that. All right, so we had an unidentified user ask if any application in Nomad, or any binary, runs containerized. Isolated, yes, depending on how you choose to run it. Containerized, not necessarily. The classic "it depends" in IT applies here very well. Anything you two want to add to that?
Yeah. I mean, so kind of the task driver is really the interface for Nomad to say, run this job, stop this job, restart, send signals to this job, send signals to this task. And then the kind of whatever the workload is really defined by that task driver. So the task driver is what defines, what those isolation characteristics are, right? So it might be a Docker container, and that's the Docker task driver. It might be, so we have like an exec, what's called the exec driver, which is a Linux container on Linux. That one runs on Linux. So that's a Linux container, right? It's built with runc, the runc library, and so it has usernames, or it has Linux namespaces, C groups, all that kind of work. But you could also have like the raw exec driver, which is literally just a process running, right? Without any kind of container around it at all. So that there, and then all the way up to and kind of going in the other direction, you have like the QEMU driver, which is okay. We're going to run a KVM instance on that as the task, right? So then that's a much stronger isolation because it's the kernel virtualization and not namespaces, right? And so that's kind of like you have that full range of capabilities available depending on which task driver you choose to make. And of course, for custom task drivers, it could be anywhere in between there. And of course, Windows has its own kind of not great isolation story, and Mac has its own isolation story, which is different than Linux. So it's also specific to like which platform you're actually deploying on.
Check out the docs at developer.hashicorp.com to learn more about the different task drivers. We could probably spend the rest of the day, no matter your time zone, talking about each task driver. The easiest way is to just get started. Let me see, Michael, I think we have a question for you here from Max Fröhlich. Is there a way to proxy the task socket API? Max built an admission controller proxy for Nomad, but the socket task API renders it useless.
Oh yeah, this is a great question. And the direct answer is probably. I think you should be able to accomplish what you want to accomplish here. So the most direct way to proxy the task socket API is to use something like the small Unix utility SOCAT to just expose a TCP/IP port and have it proxy that to the Unix domain socket, because that task API that we're talking about here right now in 1.5, that's only exposed as a Unix domain socket inside each task's environment. So like the QEMU driver doesn't work at all with yet because we have no way to get a Unix domain socket in there. And so there's some other gotchas around that as well. Like with Windows, you have to have a fairly recent version of Windows to even support Unix domain sockets. So it's kind of an imperfect situation right now, but on a lot of platforms works great. And something like a SOCAT would be able to turn that into a standard TCP/IP HTTP endpoint. Use that with group networking, and that'll use a network namespace on Linux to make sure that then you could expose the task API as a plain old HTTP server to everything within that workload, and nothing outside of that workload. The other trick with the task API, other than it being a Unix domain socket, is with the task API, it always requires authentication. I wanted to do that because I wanted to be able to make the task API just kind of always available by default. But I wanted it to also be secure. So just any workload couldn't just do anything it wanted within the cluster. So unlike the main Nomad API where you have to opt in to ACLs, the task API will always require you to give it either an ACL token or more likely the workload identity for the workload that's running right there. And that was just kind of to change Nomad's stance from a default of being unsecure, and making you opt into using ACLs to making this task API secure by default. You always have to use an identity. We'll make it really, really easy for you to use the workload's identity, but you've always got to use an identity. My evil plan for the future, just to prepare everyone, is to make it so Nomad itself works that way. So the main HTTP endpoint that we expose for interacting with Nomad will be secure by default. We won't do that without making sure it's very easy to get the credentials you need and to configure the cluster the way you need it. But yeah, that's definitely the plan, because it's always better to ship secure by default software than making you do the extra effort yourself to lock things down.
I think from an architecture perspective, it's also super interesting that we're switching from basically a fail-safe situation to a fail-secure situation, because it does mean that you're no longer leaking stuff that you shouldn't be leaking. And I like that. It's a good focus to have. It's great that we're pushing in that direction. And yeah, if you've played around with how simple the SSO setup is, I have no worries at all that workload identity is going to be harder to implement than that.
Yeah, and one other thing I quick want to mention around Max's questions with task API and workload identity. GitHub issues welcome. Like I said, we kind of shipped this as a little bit of a minimal viable product sort of situation where, doesn't work on every version of Windows, doesn't work with every task driver. That allowed us to have a lot of security benefits out of the box, but we want to hear from our users about what works and what doesn't work for them. So by all means, get on GitHub, file an issue, let us know what ideas you have for the task API.
And let us know that you came from the office hours, because that provides valuable context that we will not find in our logs if you send us a log file. I think this worked out for Max. So there we are. So one thing I like to ask all of my guests is, which of the features did you enjoy working on the most? And we'll go with you first, Tim. Any release is in scope for this. Can be a feature that was added, can be a feature that you finally got to remove.
Yeah, that's good. Yeah, I think so. Things I've worked on recently. I mean, I think like a lot of these Fortify things have been a lot of fun in that they're not just intellectually challenging, although they are, but we know that they have a big impact, right? So it's the sort of thing where, like, I wouldn't say that they're necessarily fun, because sometimes when you're like, 2 weeks in and you're just kind of beating your head on something and it's just not working, you're not able to reproduce, right? Like those are kind of challenging. I enjoy those kind of challenges, so that's always fun. I think the plan for node rejected bug was probably, like the level of evil of that bug made it so that it was a lot of fun to, like, when you finally got it, you just felt really, really good about it. Kind of more like actually fun things I worked on recently. I would say, so I worked with Charlie, who I think has been on Nomad variables. We did that last summer, and that was a lot of fun. Nice big meaty project to work on, with a lot of kind of like interesting edges, and I think it's like opening up a bunch of like really interesting like new features, because it's like, oh, now you have this key value store. It's like, oh wow, now can you have little like scoped areas to put like Nomad scoped areas to put stuff in, or and certainly what you, the users, are going to be doing with those, that feature is kind of open-ended as well, which is cool.
Yeah, so Nomad variables landed in 1.4, I think.
Yeah.
Can't believe that was last summer. Things have been going fast with new features coming out. I think back then, service discovery, a few improvements in that area as well. And I think prep work for workload identity, actually, because I remember there were token expiration things and more ACL updates.
Yeah, and it's interesting because one of the things we did with variables, and this is kind of where we made the decision to start working on workload identity at that point, because we said we didn't want you to have to configure a bunch of ACL policies for every job that you wanted to have variables. Like you wanted to, like, the idea of having like job scoped variables seemed really nice to be able to do without having any like special, like, you don't have to do any configuration at your end. You just ask for, you write the legit variable and then you ask for them in the job, and like that should just work without all that. And so to do that, we needed workload identity. And so that was kind of like the first use case for us, was to do that.
Beautiful addition. Looking back at 1.4, I just checked out the release notes again. My personal favorite, I didn't realize it's only been around since 1.4, but restarting all allocations in one go. When you're testing, I mean, obviously my production stuff never breaks, but when you're testing, having access to that kind of button is beautiful and powerful. And shortcuts, also very useful. Michael, what's your favorite feature?
This is hard. I'll go with a weird one. Nomad Operator API. I think I'm going to say that I think that might be the most popular thing I've ever done, because I just keep seeing like people use it, and it was just like, I forget if it was a hack week or just like I just like scratched an itch one day. But if you don't know what I'm talking about, Nomad Operator API is basically curl built into the Nomad binary. So if you have the Nomad binary sitting there, type Nomad Operator API, give it an HTTP path, and it'll do an HTTP request. But it includes all kinds of shortcuts for working with Nomad's API. So if you have environment variables set up for your ACL tokens, for your namespaces, for your MTLS is wonderful, but a huge hassle to set up. And especially to try to set it up with the actual curl command line utility. Nomad Operator API uses all the same plumbing that our other CLI commands do to read those environment variables, automatically set up the HTTP request, and just makes it a lot easier to poke at Nomad than to try to use curl or something else manually. So yeah, we're converting all of our docs, API docs, to use Nomad Operator API instead of curl, just because if you're using Nomad, you'll have Nomad Operator API there, guaranteed. So it should just work for you, and should just simplify a lot of having to type -uppercase H X -nomad -token, then like make sure that you use the right like variable interpolation for the shell that you're using to like get your token in there. But don't type your token, because that'll get saved to your history. And I mean, it just, all those little paper cuts just go away.
I like paper cuts that go away, and not having to type curl commands is an especially nice paper cut to take away. It's beautiful when you can fall back to that when you need to, but just looking at some of the included commands, like getting your autopilot config in an easy way, getting all your debug stuff, or what was the one that actually was super interesting? Like you said, generating an encryption key without having to remember the specific commands, and actually having a humanly worded interface, much nicer. I like it.
One of the little bonuses of that Nomad Operator API command is that, and I love it, I think it's the dry run flag on that. So it will actually output the curl command you would need to type it. So it's like, it has the exact, so if you really want to use curl, like you can,
But why expose yourself to those paper cuts? Never, don't do it if you don't need it. This has been super educational. I learned a lot over the past hour. Thank you both for sharing your knowledge with us, and fielding all those questions from the community. I like when we get to talk about the stuff we use, and especially today, I feel like we mainly talked about quality of life improvements. Yes, some new features, but These are the huge changes that happen in the background that on a change log end up being, like a single line, if that at all. Quality of life improvements generally don't rank in the flashy area of like, oh, let's put 50 cool screenshots and demos there. But it's the stuff that keeps the application going. And as somebody who ran stuff in production, I don't get paid anymore, score. Thank you for that. Also, thank you to our audience for throwing all these beautiful questions our way. Max, Daniel, unidentified LinkedIn user, and others. Thank you all. We'll have a new one new community office hours for Nomad in May, where we're going to talk about. We're going to mention that when we're ready for it, just to make sure we don't talk about stuff that we shouldn't be talking about right now. But you definitely want to check it out. We'll have 2 new guests. Michael and Tim, of course, are going to be back for HashiTalks Build in August. I'm super excited about that. And with that, any closing words from either of you?
No, it's always a pleasure. Thanks, everybody.
Thanks, everyone.
Thank you. And we'll see you at the next one.
Bye.